our first afternoon speaker, and by the way, we've gained a little bit of time because of Ed dropping out, but I just wasted some of that, is Jon Coello, who's from Improbable Worlds. John's going to talk about massive scale simulation in terms of a tool that they offer and the sort of things you can do with that. And later, I think we'll hear that that's something the Catapult is into as well. So, John, can't see you. Oh, right.
Hello. Right. Well, thank you very much, Hugh, for the introduction. I'm John, and I'm here to represent Improbable. Now, Improbable are a London-based technology company that are operating very much at the forefront of distributed simulation technology for the cloud. Now, as some of you might know, our foundations and our kind of, our company originated from the gaming space. We were really about creating a new platform to create a new breed of massive multiplayer online game. But I'm not going to be talking to you about that today. Instead, I'm going to be talking about another side to our business, which is the use of a similar, well, essentially the same simulation platform, but applying it to the non-gaming space to enable modelers such as yourselves to harness huge amounts of compute power to answer and explore some of the biggest and most complex issues that we face. And we're talking about issues such as one that's come up quite a bit today, like the introduction of connected and autonomous vehicles. I think that there is no doubt that it will be a disruptive technology and it will fundamentally change the transport industry. But how are we going to sort of explore these changes, and particularly the changes to the wider transport sector, such as how will consumer demand be affected, how will it influence environmental and economic efficiency, how will traffic and congestion change, and how will this new technology utilize the existing infrastructure? And most significantly, how will we understand, plan for, and take advantage of these changes? So for us, this is really a question of the emergent behavior of a complex system, a system that comprises many millions of heterogeneous, sophisticated, interacting entities that, when they interact at an extremely large scale, produce potentially difficult to predict system effects that result from potentially very subtle interconnections and dependencies between all of the different actors in these systems. And this is a kind of quite a common kind of problem, and there are many other problems like this, such as disasters and emergency response strategies, a large-scale supply chain disruption, massive events like the Olympics, like the World Cup, and indeed many changes to transport networks, such as introduction of disruptive technologies and the opening of major new links, such as Crossrail, such as HS2. So how can we go about understanding these kinds of issues? Well, we've heard a lot about big data, and I think big data and data analytics plays a really important role in understanding how systems function. The problem is data only shows us kind of patterns from the past, so really it's a question of how do we leverage this data to ask the kind of what-if questions about the future. Well, what if we could take something like an entire transport network and simulate it at a scale of kind of one-to-one? So we've got all of the significant entities that make up that transport network, and also all of the activities of that transport network simulated at a kind of one-to-one fidelity. Well, I think if we could do that, we could start to ask some really kind of interesting and important questions and get some really useful data out at the end. But what would it take to run this kind of simulation? Well, I think it will probably require multiple pieces of specialist software to integrate and work together to support the simulation. you would probably need many, potentially even hundreds of instances of each of these different types of software to work together to give you the scale of the entire system. And we would need a huge amount of computational resource to run all of that on. We would also need ways of ingesting data, both historical and probably real-time data feeds. And it is this set of challenges that we at Improbable are all about solving. And we are doing so with our platform, which is called Spatial OS, which is a new platform for unprecedented massive scale simulation. Spatial OS is a distributed operating system. It's designed for massive scale simulation on the cloud. It essentially works by abstracting tens, hundreds, or even thousands of physical machines to create extremely large, uninterrupted simulated spaces. It also allows the integration of new and existing technologies to support the same running simulation. And we provide tooling for the deployment and management of massive scale simulations in the cloud. So at its core, Spatial OS it has a layer that focuses on spatial compute abstraction, resilience, workload balancing, and persistence. And into this layer, we plug many pieces of third-party software, which we refer to as workers, which are then fully managed and optimized by the Spatial OS platform to support these extremely large simulations made up of potentially millions or even billions of individually simulated entities. So what this means is that we've created a platform that actually makes it possible to simulate at one-to-one fidelity models of real-world complex systems. It also means that you can take existing modeling software and scale it to tackle much larger problem spaces. And you can integrate multiple different software models written in a variety of different programming languages. Because of our gaming background, we also offer a set of very interesting ways for analysts and stakeholders to interact with running simulations, which I think is a whole different set of opportunities. So let's consider a case study of using Spatial OS for city transport system simulation. So using Spatial OS, it will be possible to simulate a huge variety and huge number of heterogeneous actors that make up the transport system. And because we don't really restrain the way that you implement these actors, it would also be possible for some of them to be extremely sophisticated, artificially intelligent agents, employing things like learning algorithms to produce like adaptive activity patterns, which I think would be a very interesting kind of addition to transport modeling. We would be able to model the deep interactions between individual agents within a simulation. All of our simulations are fully persistent, and this, I think, would allow you to do interesting things around kind of modeling the relationships between agents that might belong to the same family group, social groups, or commercial organizations. And ultimately, by thinking about a simulation in a fully persistent way, what we're creating is something that really follows the same rules as the real world, which I feel is a more intuitive way of doing simulation and thinking about simulation problems of this scale. So we could take all of the subsystems that make up the transport networks, made up talking about private, public, and freight vehicles. We could look at all different transport modes, and we could also take that simulation and build in models of related systems such as information flow, energy, maintenance operations, emergency services, etc. Now, we have had this kind of concept for a while in Improbable, and in order to kind of explore it further, we actually had the pleasure of teaming up with some of the people at Transport Systems Catapult to build out a kind of demonstration of city simulation on Spatial OS. So if we can get the video to run, yep, excellent. this is really just a kind of a basic demonstration that we've put together of simulation running at full city scale, where we're modeling the majority of major infrastructure networks, so power, telecommunications, the internet. We're also modeling all of the major utilities services. And then at the base of the simulation, and very much at the heart of it, we have the synthetic population of that city modeled at one-to-one scale, moving around the city and interacting in a basic but somewhat plausible way. And I have to say, we are not transport modelers. We have really no intention of building this out into a full-scale application. But what we have achieved, I think, is proof that this kind of modeling can be done on Spatial OS. And it would be excellent to see that taken forward. So we've really kind of created this vision of building synthetic cities based on a combination of historical and real-time data, and of utilizing the tools that exist already to sort of weave them together to create these kind of sophisticated synthetic city models. I think that there are a range of applications for this kind of technology, ranging from everything from disaster response modeling, urban planning, and vehicle fleet optimization. But as I say, we are not going to build any of these applications. We are specialists in distributed compute. We provide the simulation platform. And it's really for people like you to take that, use it, and build these kind of applications. And I think very unfortunately, we're going to have a presentation later on by Robin North from Immense Simulations, who are a company that are going to be building exactly this kind of thing in coming months. So they will tell you a bit more about the work that they're doing around sort of synthetic city building and vehicle fleet optimization. So to sum up, Spatial OS is a platform that allows you to create huge, sophisticated, persistent simulated environments. It's a platform that allows the modeler to focus on simulation logic rather than the lower level stuff like cloud deployment, workload distribution, resilience, and optimization. And it's a platform that allows you to create compelling interactive simulations using state-of-the-art technology for visualization and user interaction. So it's a platform for modelers, and it's a platform that we hope you will use to harness the power of massive scale cloud-based simulation to create some really, really interesting modeling tools in coming months and years. So thank you very much for your attention. My colleague Zara and myself will be around for the rest of the day if you'd like to discuss anything, or please also feel free to have a look and learn more about us on our website.
Great.